Hi everyone. Imagine you're shopping online and you keep getting product recommendations that don't match your interest or your search queries. Of course, it's frustrating, and this happens because of the hidden errors in the data, errors that knowledge graph outliers detection can solve. So today I will tell you how we're enhancing data with a seamless customer journey. As I said, my name is Ekaterina. I am data analyst in CCDP data team in ADEO. And before I will start my presentation, of course, I want to share with you the experts, the dream team who made this topic possible. Some of them are here today, so thank you that you're here today. Okay, first quick question. Do somebody know what is knowledge graph? Not people who had the pictures on the previous slide, please. Yes? Shortly, maybe you can share.
No,
you just know. Okay.
No pressure. I did my part.
So, knowledge graph, it's all about structuring and connecting information. Let's take a step back. Why does this matter, and how does this impact on the real world data? Today, customers, me also, expect seamless, intelligent, and personalized experience. But to achieve this, we need high quality, structured, and enhanced product data, of course. Our knowledge graph outlier detection solution ensures data accuracy, consistency, and reliability by identifying errors in the product data. We are leveraging AI, we automate data validation, enhance product categorization, and improve search and recommendation systems. And as a result, we have better customer experience, faster implementation for the business units of the knowledge graph, and more efficient operations for merchandisers and taxonomists. And what is our vision of this product is capitalizing all the expertise of the DIY we have in the machine-readable form with AI-driven solutions and enhancing with the global knowledge. And at the end, we have good data, that means good customer experience. Quickly, I will explain you what is knowledge graph. If you don't know, it's a knowledge model network of connected concepts, events, situations, relationships, events. Each piece of information has clear description in the knowledge graph, as you can see on this simple example, and helps to explain another entity in the knowledge graph. And we are talking about three main points. It's database, it's graph, and it's knowledge base. This is a simple example of what is knowledge graph in DIY world. So this is an example of our CCDP knowledge graph. It's a product and relationships between them. Of course, this work is in progress. So you can see how products potentially can connect with each other. Two main points I want to share about the terms. It's ontology and taxonomy. Ontology is a description of all structure of classes, properties, relationships, everything we have inside the knowledge graph. And taxonomy is a tree to organize a concept in a hierarchy way. And there are infinity of the relationships in the knowledge graph. It can be the broader, it means like belongs to, accessory, made of, for installation, anything. It depends on the number of ontology classes and the types. We have a lot. It's brands, colors, product sets, effects, product series, typologies, etc. So this is an example with the real products from our knowledge graph. So you can see that we have one taxonomy tree, some concepts that belongs to others, some concepts that are used to install another concept. Products belong to different levels of the hierarchy in the knowledge graph. And important thing is population rules. So it's like What population rules in action? It's an option to automatically group the products by the categories in the special concept. So we use models and model attributes to categorize products and avoid manual error in this part. So what is, I know there will be a lot of technical questions about the knowledge graph, so we are starting the technical part. What is the knowledge graph in data tools? We have the website, for example, Leroy Merlin, that retrieve the data about the product during your usage of site from Opus. Opus is search and publication common interface of the GitHub repo. Then we retrieve the taxonomies from the pool party. It's the kingdom of our taxonomists. It's a platform where we store our taxonomies and ontologies. Neo4j, it's a graph database. I will show you after, where we store taxonomies also. A lot of other information like outliers we store in MongoDB, and our favorite Google BigQuery data warehouse, where we export our calculated data. What is graph database? It's a simple example. What is it? It's an example of Neo4j from the internet. You can find others. This is how the graph database looks like. And you can use the Cipher language to query the data, like you use SQL to query the data in Google BigQuery, so we can use Cipher to query the data in Neo4j. Also, it can look like this. It's more common to our ADEO graph base, so there are some products that belongs to some concepts, more common to our ADEO knowledge graph database, and that was my face when I started to work on knowledge graph. Little joke for the atmosphere. Actually, it's spoiler. It's cool and very interesting project. So I will explain you what we did in here. Of course, we need some tabular form of our data to use in ML algorithms, in analysis, in data pipelines. So we have the tabular form of our data in Google BigQuery. Looks simple. Population rules, products, relationships, concept products catalogs. But actually, because knowledge graph, it's a very complicated organism, you need to take into consideration all the entities to, at the end, to have the proper data for your analysis. So it's also not always easy task. But we did and doing several streams on the data part in the knowledge graph. For example, it's population rule suggestions, importance calculation, relationship quality, definition generation, and others. But today I will focus on the outlier detection case, which is in prod. So I divided my speech into 4 parts. It's explain you what is the case, how we create a solution, how we distribute this solution, and how we monitor it. Of course, we need to ask the question, what is outliers and how many of them we have? What models we can use, which one is more efficient? How and in what format we can share our suggestions with the business units, and why, and what we want to monitor. So let's start with the first part. The first part is that we started with a little piece of a knowledge graph, only with one type of the concepts. It's nature of product. It's about 4,000 or 5,000 of concepts. And business estimation is we have from 1 to 5% of outliers in it. What is an outlier? For example, in here you can see the concept penseuse électrique. Sorry for my French pronunciation. And in here we should have only penseuse électrique, but we have some stuff for using the penseuse. For example, the band and other stuff, so like accessories or some products complementary for the penseuse électrique. And for now, it's the current situation. We have 8 business units that are in prod. It's 5 countries with Leroy Merlin, Bricoman France, and Obramat Spain and Portugal. We are going to the models. I will explain you 2 versions of the models our data scientists checked, and explain why we chose one and not another. The input data is designations or definitions of the product we have in our database. It can be also the description and the product name, depending on how much data we have in this designation. And we'll go into embeddings. Neil started to describe this. In the simple word, embeddings it's like mathematical form of the text or images or audio you can use in your ML algorithm to create your ML models. So in this graph, you can see an example of products we transform to the embeddings according to the designation, and potentially there are groups according to the description of the products. There is an estimation of 1 to 5% of outliers, and the first approach was to one model per concept. So it's like one versus others. So each model task is to identify if this product belongs to this special concept. And as a result of the model, it's a probability that this product belongs to this concept. Here you can see we have one potential outlier because it belongs to the class 1, because it's color green, but according to the description of the product and the probability, it should belongs to the class 3. And in here we need to identify the border, the probability threshold, where we want to filter our potential outliers. And of course we want the highest probability that we can use, but of course we need to verify all the outliers on the border of the threshold. And there is interesting approach to do, because our data scientists proposed this implementation with the agile dynamic schema of working on this model, also with LLM validation, of course, at the end. But there are some issues with this model. As you can guess, a lot of models to train, so one model per concept. So even for our small case, it's 5,000 models. A lot of time to train. We need to run the models on the whole product catalog, so it's several millions of the products. Identify thresholds for each model. All the concepts are different. Some concepts contain thousands of products, some concepts 30 products. So it's very difficult to manage this. So we have our second detection model version. It's simpler than the first one. It's better in obvious outliers. So like we are doing the huge clean of obvious outliers in the knowledge graph, and it's faster. So the idea is the same, and the model idea is term frequency inverse document frequency. So we measure the important words into the specific document. In our case, it's concept. So for all concepts of products, we identify the most important words in this concept. Here is the formula if you want. Let's go to the example. So we have 2 products, Pensos, and the second one, please read by yourself. There is a product designation, and for the concept Pensos, we identified the most important words. For example, it's Pensos, Grinder, Sander, Ponsage, and others. And according to this, the first product is not an outlier, the second one is an outlier. So, looks nice, looks good. But of course, we have some issues with this model too. It can be the words, the situations when the words are popular, but not popular, but important for this concept. And there are some tricky cases. For example, product designation contains a word with a high probability for this concept, but it's not the main word in this description. For example, the first description, it's persos. It's okay for the concept persos. It's persos, not an outlier. Simple. The second one, it's a battery pour persos. So we have the word with high probability. For us, it's an outlier, but the main word in this case is battery. But for the model, sometimes it's difficult to identify these cases, and potentially model results can be both not outliers in this case. But of course, we are missing all the time our good friend LLM in this case we can use to filter out some part of these tricky moments. So it can be directly in the BigQuery or LLM in the pipeline. It's how you want. So we're going to next part. It's my favorite part because it's data pipelines. We talked about ML pipelines, now it's data pipelines. So after we have our probabilities. So we need to use them. We need to share our suggestions with the business units, with our consumers. So we transform ML pipeline results for Opus and for business units. What we are doing, we define and apply thresholds in our data pipelines. We convert the formats for Opus. We enrich the data with the details because, of course, just the probability and the concept ID, it's not enough for business users. We are calculating dimensions and metrics for the analysis, and we check the data quality. Here it's we are using DBT pipeline and elementary. It's very sad they are not paying me for this, but I really recommend you to check if you're a data analyst or data engineer these tools, because it's an easy data engineer tools to create the data pipelines. So thank you for the owners of this. Okay, and at the end we have the multi-BU, multi-environment transformed data for our business units LM and for Bricoman and Obramat. Here is a part of our schema of the data pipeline. And at the end, we have a qualitative, enriched, and lined scheduled data with no manual work. And with elementary, we have a Slack alerting if our data pipelines have some problems or some anomalies, freshness issues, etc. And for monitor, I don't want to focus a lot on this. We just have a Looker project with our pipeline, our dashboards, to share with the business unit who doesn't have an access for Opus to check the information, with a little bit of analysis which concepts are most problematic according to the number of outliers, so they can monitor and make some actions on this. So I will show you the schema before and after outlier detection with this approach. So as you remember, as it was. So I will show you the steps of our technical part. The first one is an ML pipeline, as Neil, I think Neil also shared ML Ops framework for the ML pipeline. So we'll retrieve the data for the ML pipeline and create the deployment with Vertex.AI on the Google Cloud with the perfect orchestration for this pipeline. Then, of course, we store our model data in the BigQuery. Then we retrieve the data for the DBT pipeline from the BigQuery and run this pipeline deployment with the GitHub Actions for the multi-BU environment. We have the perfect deployment on this part and also perfect orchestration after. And as a schedule, we have an elementary test with a Slack alerting for the data pipeline problems. We store the multi-BU results for Opus in Google BigQuery and multi-BU results for database, because we are preparing the whole data for our dashboarding before the dashboarding with all calculations. And we retrieve this data for our database part. So the schema now looks approximately like this, I hope. Next step, okay, we created our suggestions, we applied threshold. Next, we need to change something in the knowledge graph. So we have the validation part on the opus side. So we have opus, we have the special part of the opus, especially for the knowledge graph. We go to some concept, we go to the blacklisted product we have inside, and here now we have the human verification, the next step, the last step of this process. If it's yes or no, according to the business specialist, they verified and approved or disapproved our suggestions. But with this process, we automized as maximum all steps before just verification for the humans. And this is our improvement, in this case, outlier detection for the knowledge graph. But it's continuous improvement because it's only one little piece of this product. And here is just small examples of what we did, doing, or will do on this topic. And I want to show you, as a result, what is the correct content for the customer. So, imagine you are going to Leroy Merlin site, it's Leroy Merlin France, and want to search some barbecue products. You create a search query. As a result, you have results without the blacklisted products. It's like the shadow result for the customer. The customer is just happy because it's what he or she wanted, but it was a huge work behind. So we have a customer, there's good queries and good recommendations, and thanks Leroy Merlin, they will return next time. Thank you.